Greetings for the day. Myself, Dr. Nidhya, working as Professor in Computer Science and Engineering Department, Madanapalle Institute of Technology and Science. In this series, we are going to discuss about compiler design, which is the most important topic of the computer science professionals. In this lecture series, we are going to discuss about few things that is most important in compiler design. Today, it is an introductory lecture about compiler design and what are the things we are going to cover in our particular lecture series. In this lecture, I am going to cover about what is compiler, what is the difference between compiler and interpreter, and what are the cousins of compiler. These are the new terminologies to a general person actually. And what are the, why we want to learn compiler. All those things we will discuss in the first week. And upcoming weeks, we will discuss about phases of the compiler, what is the importance of lexicon analyzer, syntax analyzer, semantic analyzer, and various phases of compiler. Everything we will discuss in detail. So this is what the overall view of our course. Today we are going to discuss about introduction to compilers. So hope you all know what is compiler. This is my flow of presentation today. Compilers and interpreters, cousins of compiler. Why learn about compilers, the evolution of programming language, and end with the summary sheet. And first, let me introduce about what is compiler. So before we start about the compiler, I want to give you a small recap about the thing what you know already. So generally, we use it to call the programming languages in three various types, right? Generally, languages are divided into three various types. What are they? High-level language, low-level language, and middle-level language. What is high-level language? The language which a human can read but machine cannot read is called as the high-level language. For example, our English. And next one, low-level language. What a machine can read but a human cannot understand. What a machine can understand, everyone knows that machine can understand only zeros and ones. That is nothing but binary. So, in that case, if I'm writing everything in zeros and ones, how a human can read it is unreadable format, right? So that's the reason it is called as the low-level language. So something called as middle-level language. That is generally we call it as the assembly-level language. So what is assembly-level language? It is a combination of high-level language and the low-level language. Hope we all know about the assembly-level language, like writing a microprocessor coding, like add R0, R1. Like that, we have written something, right? In your previous courses, definitely you must have come across these terminologies. So this is called as the assembly level language. So why I'm telling all those things? So there is a connection between these languages and compiler. See, when I'm writing a programs in high level language, which is nothing but a human can understand, which a machine cannot understand. Like all the programming languages, as of now, you may studied C, C++, Java, Python, whatever the programming language you have studied so far, everything we are writing in zeros and ones? Definitely not. We are writing everything in terms of English, general English, that a human can understand. Yeah, absolutely, we are following a certain structure. Even though structure is there, but the entire commands we are writing using the normal English. So a human can understand completely. But all those code for whom we are writing, we are writing for the system only, right? But what a system can understand? System can understand only zeros and ones. Okay, I have written code in normal English, but machine can understand only zeros and ones. Then what can I do with my programming now? So some way the program should be converted into the machine understandable language, right? So that's the place the compiler coming into the existence. Okay, so what the compiler will do? The compiler will do the translation of program written in a source language to the semantically equivalent to the program written in target language. You underline these words when you are studying in your first year, first semester or something. When you are first time studying about compiler, we must have come across with the definition like compiler is converting the process of converting high level language into low level language. But here I'm showing like semantically equivalent program written in a target language. Why I'm telling that word, we will come within a few slides. I will tell you why I'm telling that one. Actually, what the compiler is producing is not machine level language. The compiler alone cannot do this task at all. In lower classes, you must have studied those terminologies, but here we are going to study in detail about those things. Okay, so that's the reason I have given here very clearly semantically equivalent program written in a target language. So here some source program I am giving to the compiler. If you are having any error in your source code, that will be reflected. If you don't have any error, that will be ended to the target program. I already told the target program is almost semantically equivalent to the machine level program, but it is not a machine level code. There you are processing the input, where you are getting the actual output what you want from the compiler. Okay, okay, so okay, in that case, how a compiler can produce machine understandable code, that I already told you, that I will tell you in a few slides. Again, there is a perfect definition of compiler here. A compiler is a program. It is even compiler is also a program. That is the highlight of here. Mostly, most of the compiler codes is written in C or something. Hope you all aware of it, right? The compiler is a program translates a program written in high level language that is suitable for human programmers into the low machine level language that is required by the computers. But this is the typical compiler definition. But what I shown you in the previous slide is the technical compiler definition. Okay, during this process, what it will do, the compiler will also attempt to spot and report obvious programming mistakes that detect during the translation process. So this is what we have shown in the previous slide in terms of the diagram, right? So now we are moving forward. Why we use the high level language for programming language? Why we can't use the middle level language or low level language? No? So definitely there is a reason, right? I'm right. I want to write a print of hi hello world. This program I want to write. Say for example, you are using the I will take a Python program because it's very easy, right? So we'll go for a Python coding. What I will do, print open parenthesis within double quote, I will write hello. That's it. Over. If suppose I'm going for the C programming, I will add the header line, I mean header file hash include stdio.h void main open and close curly break bracket, and I can write it print of hello world, like that I have to write. Even if I'm missing open curly braces or semicolon or somewhere else I'm doing any mistake, that will be highlighted during my compiler time, right? Okay, instead of that, you don't have English at all. You just imagine like you are writing your program in a either assembly level code, or you are writing in terms of binary. So if it is a equivalent number is 65. How the 65 can be written in a binary? Again, we have to decode the number, right? So it will be written in 8 bits of data. So for one character, I have to write 8 bits of data, and similarly it will be having the each and every one. On that case, you just imagine one print print will take how many zeros and ones, and how will you classify whether the first eight belongs to P or second eight is belongs to P? This kind of problems will come. So to avoid all these things only, these high level programming languages came into the existence. So that is the place where we are enjoying our programming languages nowadays. But it is very important, without compiler, those programming languages cannot work at all. And you may ask the question, why I have to know all those things? It is already available. I simply execute the process. Yeah, it's completely fine. But when you want to deliver your code in a very much optimized code, now AI is doing everything, but still how that AI is processing, how that the code is, how you want to write the effective coding. When you know the compiler process only, you can write the effective code. If you don't know what is the process the compiler is doing, definitely you can't tell what is actually happening in the inside, right? As a common man, it's no need to tell, but as a computer science person, it's definitely we must aware of how the compiler is working completely. So this is the main purpose of this course. And compared to machine learning, the notation used by programming languages closer to the way human thinks about problems. So that's why we are using the high level language. This is the foremost reason. And next one, compiler can spot some obvious programming mistakes. So that is another one. The program written in high level language tend to be a shorter than equivalent programs written in a machine language. You remember the print statement? PRINT, it's simple 5 characters, but if I am converting into the binaries, you just imagine how many zeros and ones I have to put it in that place. Okay, the same program can be compiled by many different machine languages, and hence to be brought on the run on many different machines. So that is the reason we are using those things. Okay, so this is the reason for using high level programming language. Okay, basically, when you are converting your high level language into the machine level language, there are two different machines we are using actually. One is the compiler, another one is the interpreter. So compiler, I told you already, that is converting. Okay, what interpreter will do? Yeah, interpreter also will do the same thing. It will convert the high level language into the machine understandable format. You have seen, right? I am giving a source input, I am giving a source program, and input also I am giving interpreter. So if it is an error, it will tell you the error, else it will produce the output directly. You can see the difference between the compiler and interpreter, right? In compiler, where I have given after the some target language has been produced, I am passing the input so that I'm getting my output there, right? But here it is not the case. When I am starting checking my program, when I am submitting my code to the interpreter, at that time itself I am giving my input as well. So if the code is perfectly fine, it will give me the output. If it is not, it will give me the error. Okay. And another one important difference I want to highlight about compiler and interpreter is compiler will take the entire program as a bulk. Okay, it will give you the errors if there is anything. It will take if you have written 100 lines of code, it will check all the 100 lines of code. At the end, it will tell, okay, you have done mistake in line 1 and line 3, line 10, line 20, like that sequence. It will give you all the errors, mostly which are all it can predict. One more thing, compiler can predict all the errors, but whatever it can predict logical or syntax error, it will be listed out there. But when it is coming to the interpreter, if you have done a mistake in line 1, your program will not move above the line 1. You have to correct that line 1 error, then only you can move forward. This is the another one important problem in the interpreter. So line by interpreter is the line by line execution. If there is an error in one line, it won't proceed to the further line. You have to correct the errors. If you are having 100 line code, suppose you have done mistake in line 1 and line 10 and line 20, say for example in your interpreter program. Then first time it will tell you only one line error. You have to correct. You are thinking, okay, only one error. No, it's just it attempted, it find error, it stopped there. Once you correct that error, and again it will cross checking the other codes. When again it's attempting the 10th line code, it will struck there. It will tell you like you have done mistake in the 10th. So likewise it will go. So this is the compiler and interpreter major difference. So here we have given the clear-cut difference between the compiler and interpreter. It takes the entire program as the input, but interpreter will take single instruction as the input. It works faster. Why? Because instead of getting one error at a time, see if you are writing a code of 5 lines, it's not a problem. But when you are writing a codes of 1,000 lines or 10,000 lines code, every line you are getting error. So it is a quite difficult process, right? So that's the reason compiler is faster and interpreter is slower. And intermediate object code is generated. You remember I have shown in the diagram, in compiler there is something called target program. There only you are giving the input, then you are getting the output. But in interpreter, I have shown you like there is no intermediate code at all. Directly you are passing input along with the program, it is producing the output. So there is intermediate object code in your compiler. There is no intermediate code in the interpreter, and require more memory due to intermediate object code, and require less memory as no intermediate code is available at all. And program need to compile every time, but here every time higher level program is converted into the lower level program. So this is the another one most important difference. And errors are displayed after the entire program is checked, but as I mentioned already, every instruction it will give you the error. And debugging is comparatively hard, but why it is hard and easy, hope you can understand now, right? Because here line by line when I'm checking, I find the mistake in the first line so that I can correct and I can move forward. Here it is giving on the whole one time. When there is a pro, definitely there will be a con. So the problem is when it is giving on the whole picture, the debugging is little bit hard in a C language, I mean compiler based languages. Interpreted is debugging is very easy. Example for compiler is C and C++, and interpreter is Python, Ruby, Basic, all those languages are the example for interpreter. Hope you got the clarity between the compiler and the interpreter. Now we are moving on to the next slide. That is nothing but hybrid compiler. So what is hybrid compiler? The hybrid compiler is a kind of thing what a compiler and interpreter can do together. So that is called as a hybrid compiler. What I am doing, I am giving a source program. It is giving me the intermediate code. There I am giving the input. There I am using the virtual machine as the interpreter. Hope you all heard about the Java execution, right? How it is working with the Java virtual machine, right? So that is the concept called hybrid machine. So where I am getting the output. So compilation and interpretation may be combined to implement a programming languages. So their intermediate code can be executed at any platform. Once I am getting the intermediate code, it can be executed anywhere. I don't want the source code at all, right? So this is another one important thing in the hybrid compiler. The example is Java programming. Okay, hope you got clarity between what is the compiler, what is the interpreter, and what is the... Okay, now we came to the point. You remember during our first slide, I have shown you for something. Compiler is converting the high-level language into the relatively target code. I told you I will come to this particular point later on. Now the point came. So here you can see the diagram, right? So far, we have learned from our lower classes like I'm giving the source program to the compiler, it producing me the absolute machine code. That is nothing but the typical machine code. What machine can understand. That is nothing but simply binary, zeros and ones. This is what we are thinking so far, right? But this is not the case here. In addition to that particular compiler, we have three more components with that. Actually, we use it to call it as the cousins of compiler. Okay, the compiler alone not making the high level programming language into the machine understandable code. It is along with few other tools also we are using to make it as the machine level code. So maybe in lower classes we don't have the chance to discuss those things that time only, but here the major role taken by the compiler, so that we are discussing about always compiler. But in addition to the, since we are in the subject, we should know the minute things also, so that I am telling you these are all known as the cousins of compiler who helps you to produce the machine level code from the high level code. Okay, now we are sending the source program to the first and foremost cousins of the compiler is preprocessor. So what is preprocessor? Hope you know, right? Hash include, hash define, whatever you are giving, that is known as the preprocessor, right? When I am adding hash include, which means that I have to add one particular library into my current working program. Say for example, stdio.h I am adding. So when I am adding stdio.h, which means that a printf, scanf, all those statements, I can use it, right? So that's the thing I'm using stdio. What are the functions binded with that particular library program will be added here. Okay, how I'm doing it? The compiler is not doing it. That part is done by preprocessor. So this is the thing you have to know here. Hash define, if I'm giving, the compiler will come to know like hash define one particular value I'm defining at the global level, right? So here, who will do that one? How the compiler will know that? That preprocessor will do all the preprocessing things, then that will be passed to the next level. So what it will do, the preprocessor will check what are all the hash symbol, hash define, hash include, whatever the terminologies you have passed in your skeletal source program, everything will be scanned here, then it will be passed to the next phase of the processing. Okay, this is also called as language processing system also. We use it to tell, but generally it is also called as the cousins of compiler. Okay, so I am giving a source program to the preprocessor where it is checking a hash define, hash include all the pre-processing terminologies. Then it is processing that particular source program to the compiler. Okay, this box is looking one, but this one box only we are studying it as the 5 units of subjects. It is doing a wonders actually. These things we will discuss in our further classes. Okay, now I'm not at all going to touch that, but I will tell you one thing. This compiler is works in 6 different phases. Okay, 6 different phases are there. In that 6 different phases, whatever the program you are passing, that program will be divided into small parts, and then only it is delivering the assembly level code as the output. Here you have to note the compiler is producing not machine level code, the compiler is producing target assembly level code. What is assembly program? Assembly program is considered as the middle level language. It is not the machine level language. Okay, ma'am, how I can convert this middle level language into the high level language? Yeah, there are some more tools also working along with the compiler. They are nothing but assembler and the linker. So assembler, what it will do, what are all the assembly, like add function, like that it will give add r0 comma r1. What are all the add function is that those functions will be replaced in this particular assembler section. Okay, so since it is the assembly level code, what are the things should be replaced in the assembly level code? Those things will be taken care by the assembler. Then what it will do? It will give relatable object code. On that case, add is replaced by some kind of instructions, and R0 and R1 is given in the instruction. You consider I have a add of R0 comma R1. Then what is the instruction related to R that I have replaced in that assembler part? So add is also replaced with a certain instruction followed by R0 comma R1. So you know R0 and R1 are the registers which is having the certain value to be in a temporary way. In that case, it is called as a relocatable object code. So what I want to know now, all those relocatable objects code should be completely replaced with the actual binary code. So that process is done by the linker. So what the linker will do, it will relate it to the all the libraries and relocatable object files. Everything will be replaced in the linker part. Then finally, it will produce the absolute machine code as the output. You got it right? I have given the skeletal source program. I got absolute machine code. Actually, we use it to call the process of giving high level program to get the machine level code is called as the compiler. That is what we come to know the definition so far. But it's not the actual scenario. I have given the source program to the preprocessor. It has checked all the pre-processing material. It passed it to the compiler. Compiler has converted the pre-processed document into the assembly code. Then it is passed it to the assembler to get the relocatable object code. There, that libraries, relocatable object files, everything replaced through the linker. Then finally, I am getting absolute machine code as the output. Okay, this is how the compiler is working. This is also called as the language processing system, or it also called as the cousins of compiler. Okay, so it is most important thing, kindly note it down. Okay, why learn about compiler? This slide already we have discussed. As a common man, they need not to be know about compiler, because for them it's a kind of tool used to convert the high level program into the machine level program. But when you are a computer science student, it's much and more important that you have to learn about compiler, because how it is working. When you are going to do any kind of research, or you are going to write any code in an optimized way, definitely you must have know how the compiler is working, how it is taking an optimized path. Everything should be, we must be much aware. So that's the reason we are learning about the compilers. Since we will go through a slide once, it is considered the topic that should know in order to well structured in computer science. That's the point I told you. A good craftsman should know his tools, and compilers are important tools for programmers and computer scientists. It's not for common man, right? The techniques used for constructing a compiler are useful for other purposes as well. There is a good chance that the programmer, computer sciences, will need to write a compiler or interpreter for a domain specific language. Suppose, hope you all know, like how the Python language come into the existence. Definitely, when we are learning the Python program, you must have come across the history of learning the Python program came into the existence. Why it came? Because that particular programmer don't like the way of executing Java program, C program, C++. He don't like. So what do you want? He wants certain a program and execution much easier than the C and Java or other existing programming language. So that's the reason he got some other new programming language called Python program. How it came into the existence? Once you know how these things are happening, then you will come to know what are the difficulties that compiler is having. Those things we can rectify, and we can produce our own domain specific language. Okay, it is possible only you know about the compiler part. Okay, so another one important thing, what are the evolution of programming languages? Okay, the classification based for the programming language based on the generation. There are many different type of programming language. The difference are there. Here the classification is completely based on the generation. There are 5 different generations are there. First generation, second generation, third, fourth, 5. So the first generation is completely based on machine level languages. Hope you know about long ago, so long ago, when they are starting the first time computer inventing and all. Then little bit they have come across, then Fortran, Gopal, those kind of assembly level languages and all come into the existence. Then third generation languages, that is higher level. Even that Fortran, Gopal is third generation language for their thing, but for us it is like a second generation language only, because you don't understand the Fortran, Gopal and all. It's very old language that writing one line of hello program, you have to write one page of code. That much difficult it is. Then here C, C++, C Sharp, Java, Python, all those programming will be higher level language. All higher level languages will be considered as a third generation language, where you are using normal English as your coding part. Then fourth languages, it is the domain specific applications. You can use the particular language for a particular domain. You can't use it for general purpose. Whatever we have seen here, this is a general purpose languages. You can use it for one college purpose, one gaming, or one scientific purpose. Anything can be done. But here, suppose you are using anything for a particular domain alone. Nomad for report generation, SQL for database queries, and PostScript for text formatting. Like that, it is specific to particular domain. That is called as the fourth generation. The next generation is fifth generation language, has been applied to logic and constraint based language. Hope you all know about Prolog and OPS file language, right? That is logic and constraint based languages called as the fifth generation languages. Basically, we are using third generation language. That is what the conclusion. So this is how we can differentiate the programming language based upon the generation. Okay. Okay. So what we have discussed so far is we have started discussing about what is the difference between compiler and interpreter, what is the importance of compiler, and what is the hybrid compiler, and we have started discussing about how that cousins of compilers are working along with the compiler to produce the target machine code, right? And similarly, we have discussed about why we are writing a program in only higher level language, not in a lower level language. And at the end, we have discussed about what is the necessary for learning about the compiler. Okay, so this is what our today's session. Thank you for listening to me. In our further class, we will discuss about the phases of compiler and how that things are decoded in the compiler part. Hope you understand, right? The second part of the language processing system we are going to discuss in detail in the next lecture. Thank you.